right. Thank you very much to the organizers for putting the paper on the program. This is joint work with Tomasz and Amit, who are in the room, and Gregor Matvos, who's at Northwestern. And our paper, we're thinking through how to think about macroprudential policy in a world where banks do less and less lending on their balance sheets. So what do I mean by that? Currently, banks sell a large share of the loans they originate. So this is true in mortgages. This is true in auto loans. It's true in credit cards. It's true in corporate loans. It's true in many, many credit markets here and around the world. In the mortgage market, banks now sell about 50% of the loans they originate. Okay, and it goes beyond this. Now non-bank lenders are getting into the game, and they're originating a large share of loans as well. It's true in the same markets. And again, in the mortgage market, non-banks are making about 60% of all the loans out there. And so putting those two things together, what you find is that bank balance sheets are financing only about 20% of residential loans. Okay, and what we're going to be after in our paper is thinking through how the failure to recognize what we'll sort of call the aspect of this IO of the financial sector can lead to systematic errors in measurement and accounting in terms of aggregate time series patterns and regional patterns, and also will lead researchers and policymakers to sort of think through misspecified or misestimated macrofinance models. So what are we going to do in this paper? The first thing will be a measurement exercise. And what we'll do is document a lot of time and regional variation in what I'm going to define shortly as a loan sale and shadow bank multiplier. I'll show you that these multipliers respond endogenously to what is a key state variable in a lot of macrofinance models, which is bank capitalization. And then I'll show you how failing to account for these multipliers will lead to some qualitative and quantitative errors in inference when thinking through the health of the lending market overall. Okay. Then in the second part of the paper, we're going to write down an economic quantitative model with a richer intermediation sector. And we're going to use this model to think through impulse responses to financial shocks in a world with and without these margins of substitution. And then we're going to do an exercise where we document the sort of inferences a researcher or a policymaker would make if he or she had a misspecified model or estimated that model with data that doesn't fully capture these margins of substitution. Okay, and sort of the policy and research implications here are that it's going to be very important to incorporate what we'll call the IO of the financial sector in a lot of these macrofinance models. Okay, so our focus here, it's going to be on the 11 trillion plus US residential mortgage lending market. As you may know, this is the largest private debt market in the US. And what's really going to be nice about this market for our exercise is the data is very good. So we'll be able to observe every single loan origination, whether it's financed through a bank balance sheet or through something else. Okay, and these lessons are going to apply to other market segments where we know sort of anecdotally that this shifting away from bank balance sheet lending is happening, but it's just harder to observe in the data that's available. Okay, so let me first define what we'll call the loan sales lending multiplier. And we'll look at bank I at time t, and that bank's total lending will be equal to this multiplier times the bank's balance sheet lending. So bank balance sheet lending will be a subset of its total lending. And just rearrange this definitionally, we'll find that this loan sale multiplier is equal to 1/1 minus that bank's loan sale share. Okay, so that's at the bank level. We can also define this as at a sort of aggregate level and measure total bank lending as the aggregate loan sale multiplier times bank balance sheet lending. Okay. Second multiplier we'll think about is the shadow bank lending multiplier. And again, we're going to define total lending or aggregate lending as this shadow bank multiplier, which will vary over time, times total bank lending. And again, rearranging that, you get that the multiplier is equal to 1/1 minus the shadow bank share. Okay, then putting these things together, sort of total lending in the economy will be the shadow bank multiplier times the loan sale multiplier times this bank balance sheet lending amount. Okay, and so for various reasons, regulators and academics are often sort of focused on this bank balance sheet lending component of that. Part of that is because sort of traditionally that's where we think of a lot of financing coming from. And partly that's what's really easy to measure in a lot of data. If you go and look at bank balance sheets, call reports, that's kind of what you'll observe. So that would be fine if the world that we lived in was a world where banks are doing everything with their balance sheet. So if there were no shadow banks, shadow bank lending multiplier would be 1. If banks retained everything they originated on their balance sheet, the loan sale multiplier would be 1. And then measuring total lending with balance sheet lending is the right thing to do. But as I'm about to show you, this is just not the world that we live in. So this is the composition of lending in the residential mortgage market. The red is the bank balance sheet lending. this is what you would observe if you just looked at sort of bank call reports. The blue is what banks are originating but are selling very quickly. And the green is so-called shadow bank origination. Okay, and what I'm going to do is sort of translate these into the multipliers I just defined and go through a couple important facts about these, the dynamics of this. Okay, so the first fact is that there's dramatic time variation in these multipliers. So what I'm showing here is a sort of traditional bank balance sheet model. If that's the model we live in, then this multiplier would be 1. I'll layer on the loan sale multiplier. Two things to notice: the average is over 2, so it's a big quantitative number, and there's a lot of time series variation in this. I'll layer on the shadow bank lending multiplier. Again, the average is well above 1. It's about 1.5, and there's a lot of time series variation there. Okay, then multiplying these together, you get the total multiplier. The average is something like 3.5. There's dramatic spikes. There's very small, there's troughs. Right now, it's about 4.5, meaning for every loan that's originated on a bank balance sheet, there's about 4.5 loans that are like really originated out there in the economy. Okay, so the fact that there's a lot of time series variation in this means that balance sheet lending is going to be sort of a poor proxy for total lending that's going on in the economy. And the exercise we're going to do is regress total bank lending on bank balance sheet lending, or we'll regress aggregate lending on total bank lending. And we'll find that we'll do this either at the aggregate level or we'll do it at the county level. We'll find that we're able to explain something only like 44% of the variation in total bank lending with just bank balance sheet lending. At the county level, that number is about the same. You can add in county and year fixed effects, and you're still not really able to explain a lot of the variation. Then in terms of total lending, total bank lending can only explain something like 70% of total lending in the economy. Okay, so there's a lot that's left unexplained if you're only observing the balance sheet. So putting facts 1 and 2 together, it's going to mean that there's sort of big inference errors if you're trying to get to total lending from observing just bank balance sheet lending. So a simple exercise you could do is just say, okay, let's scale up bank balance sheet lending by the long-term average. If you do that, you'll get this red dotted line. And what you can see, because of this time variation, you're going to get these systematic and persistent overshootings and undershootings in terms of how you measure this stuff. Okay, that's true both at the bank level, and then it's true sort of in aggregate lending level. That's going to suggest the fact that there's these sort of persistent overshooting and undershooting of this, that there's some important state variable behind this that we want to think about and try to identify. And we're going to identify that as bank capitalization. So what we'll do on the left is just regress the fraction of loans that are retained on balance sheet on the sort of aggregate capital ratio in the economy. On the right, we'll do that within banks. And we can see that when banks are better capitalized, they're retaining more on balance sheet, meaning this multiplier is going to be moving up and down with a lot of, with this kind of key state variable. Okay, and then sort of finally, the last fact is I've been focusing mostly on time series variation. There's also a lot of regional variation in this as well. So in the upper left, I'm showing you the sold share. So what banks are originating and selling, and on the lower right, I'm showing you the shadow bank share. And again, there's a lot of regional heterogeneity. And if you kind of look at the demographics that this lines up with, you'll see things like low income areas have large share of loans sold by banks, and they have a greater presence of shadow banks. So to the extent that there's some concern about differential risk of these people or different access to credit, these margins are going to be very important to them. Okay, so those are sort of the empirical facts that are going to motivate the model. We've showed you that if you sort of ignore these facts, you're going to miss sort of measurement and sort of aggregate conclusions about what's going on. We want to write down a model that will sort of let us think this through in the context of some policy counterfactuals that people will often do. Okay, so we want to write down a model that will have this loan sale margin, that will have this shadow bank margin, and then importantly, we want this to be able to vary endogenously and realistically with the key state variable that's driving a lot of these models, which is bank capitalization. Okay. So how are we going to do it? We're going to add dynamics to essentially an IO style model that me and co-authors have worked on previously. The work that the IO is going to do here is going to tell us how banks and non-banks compete with each other, how good they are in terms of providing substitute credit for one another. And then what's going to be there is there's sort of endogenous competition and an endogenous bank financing choice. We'll add dynamics to that by incorporating bank capital as the key state variable, and that will evolve over time and drive the decisions that banks are making. Okay, and then with the calibrated model, we're going to trace out impulse responses to capital shocks with these margins on and with these margins off. Think about what the margins are doing to lending responses in the economy. And then, as I mentioned, we'll do this exercise where we'll sort of pretend we're an economist who isn't aware of these margins and tries to calibrate a model without them, and think about the inference errors you would make if you were running a model like that. Okay, so the model setup, I'll talk through the within period market first. This is sort of like the IO part of the model. There's going to be an exogenous loan demand. People like loans, they dislike interest rates, and then they have some preferences over the lenders. So they view banks and non-banks as different, for example. What the IO is going to tell us is what these markups look like, how banks and non-banks are substitutable or not. Okay, then there's going to be loan supply from short-lived shadow banks, and they'll just be maximizing profits. They'll take other people's interest rates as given, set interest rates to maximize that. And then banks will be long-lived. They'll have this similar profit function where they're setting interest rates. And importantly, they're also making a financing choice, which is given by phi. So phi equals 0 means the bank sells the loan. Phi equals 1 means the bank retains the loan on balance sheet. That's going to make a difference for the marginal cost that the bank faces. Think of that as representing some securitization cost, as being a reduced form for some selection that the bank might engage in when choosing which loans to sell and retain. Okay, it's also going to have a capital impact, which I'll talk about on the next slide, which is where we go through the bank's dynamic problem. Okay, so bank capital will follow this law of motion. We'll say that next period's capital is equal to a shock times this period's capital plus investment that goes into the firm. So I is positive means we're raising capital, I is negative means we're taking dividends out of the firm, plus the firm's profit from lending. Okay. Now, as sort of a shorthand way to capture sort of net worth constraints or regulatory penalties that show up in a lot of these models, we're going to define an effective capital ratio as sort of what the regulator is paying attention to, and it will be equal to the shocked capital minus the capital that is deployed to finance the loans that the bank is retaining on balance sheet. Okay. So with that in mind, the flow utility for a period, given the rate R, the retention choice phi, and the regulatory penalty rho, which is going to, again, capture regulators punishing the banks for being poorly capitalized, and investment I, the banker will like consuming dividends, and then they'll sometimes be penalized if their capital is too low. Okay. And then what the bank is trying to do is maximize its value function, which is the discounted sum of its period utilities, choosing the path of interest rates, retention choice, and investment into the bank. Okay, so that's sort of the baseline model that has these margins. We're going to compare this with the what I'll call the neither margin model, which will do two things. It will get rid of shadow banks, and then it will force banks to retain everything that they own on balance sheet. And we're going to sort of compare these two models. So we'll calibrate the models with a bunch of moments in the data. Let me just kind of highlight the key things. We're going to be matching the dynamics of these multipliers. So we'll try to get the levels of them right. We'll try to get the variance of them right. And then importantly, we'll try to get the correlation between bank balance sheet capital and bank balance sheet lending right. And the model is going to endogenously generate these moments. Okay, so with the calibrated model, I'll just walk you through some intuition with the bank's policy function. The blue will be the baseline model, and the dotted red will be the model with the margins turned off. The kind of key intuition that's going to be common across all of this is that with these margins, shocks to bank capital are going to cause the bank to substitute towards these other financing sources instead of changing things around through interest rates or quantities. Without the margins, the bank is going to have to finance things on balance sheet, which will mean that there'll be big increases in interest rates and big effects on quantities. Okay, so what do you notice? First, as we plot responses along bank capital in the baseline model and in the neither margin model, nothing is really happening when the banks are well capitalized. This only matters when the bank is in a sort of region of the state space where they become impaired on their balance sheet. The upper left, I'm showing the fraction of loans that the bank retains on balance sheet. Mechanically, in the neither margin model, they retain everything. But in the model where they're allowed to substitute off, they kind of endogenously start selling loans rather than financing them on their expensive balance sheets. So upper right, that's showing the bank's investment policy. The bank, when they're well capitalized, they're paying out a small dividend. And when they're poorly capitalized, they go out and raise capital. How does that get translated into interest rates? So on the lower left, you see in the baseline model, when the bank is sort of poorly capitalized, they have to substitute towards slightly more expensive off-balance sheet financing. So rates rise a little bit, but it's much smaller than the effect when banks don't have the substitution margin. They have to sort of finance these things on balance sheet capital, which is very expensive. And then, of course, that translates into big changes in quantities as well. Okay, so with the model, we're going to do these impulse responses. The sort of policy experiment we're going to have in mind here is we'll give a big negative shock to capital. Think of this like one of the assets on the bank has a big impairment in its value, and we'll trace out what happens across the scenarios. Okay, upper left, that's showing what happens to the bank's capital with the same shock. We give them the same shock. The kind of important thing to notice here, a couple of things to notice. First, the baseline kind of steady state level of capital is going to be higher with these margins turned off. Okay, so what's going on there? Well, when the bank relies on the balance sheet to earn profits, to sort of do its loan financing, it's sort of, that balance sheet space is much more valuable to the bank. So the bank wants to be more conservative in the amount of capital it has. On the other hand, when this alternative way to finance loans and earn profits exists, the bank can be a little bit more risky in terms of the steady state level of capital that it's maintaining. Okay, and then you can see that in the response to the shock, in the baseline model with that big shock, the bank can recover a lot more quickly because they can recapitalize through retained earnings that they get through selling loans in the secondary market. It's much harder for them to do that if they have to originate on their impaired balance sheet. Okay, so how does this look in terms of lending quantities and rates? The upper right shows what happens to interest rates. With no margin, there's a big impact on interest rates. It's about 1 percentage point, which translates into about a 30% increase over the baseline level. And in terms of quantities, it's about a 60% reduction in the amount of lending. And you can see when these margins exist, the size of these shocks as translated to the lending market are much, much smaller because they can substitute towards other financing sources. Okay, so in the last bit of the talk, I'm going to walk you through this sort of misspecified calibration exercise. And the sort of exercise we have in mind here is there's going to be a researcher who gets the measurement a little bit wrong and gets the model a little bit wrong. And so what do they do in terms of measurement? They'll measure total lending, which is kind of the easy thing to measure from, for example, Fed flow of funds. And they'll measure bank capitalization, which is easy to measure from bank call reports. And then they'll put this together in a model that omits this loan sale and shadow bank multiplier. Okay, and then we're going to calibrate a model like that to the moments we see in the data to show you exactly what we're doing. In the baseline specification, that's what I showed you before, we're allowing these margins to be active, and we're trying to hit the correlation between balance sheet lending and bank capital ratios. In this counterfactual calibration, we're turning off the margins, and we're trying to hit the correlation between total lending and bank capital ratios, which empirically is a much, much smaller correlation because in the true data generating process, these margins of substitution exist. Okay, so this is the result we get. So I'm showing the blue is kind of the baseline model calibrated correctly with both margins. The red solid line is the baseline calibration calibrated correctly, but we've just turned the margins off. And the dotted red is the counterfactual calibration that sort of forgot about these margins when doing the calibration. And what we get is that the sort of predicted response of the misspecified calibration kind of falls halfway in between the sort of true model with both margins and the true model with neither margin active. So what's going on there? Well, the misspecified calibration is kind of forced to thread this very uncomfortable set of empirical facts, which are that total lending and bank capital actually have a pretty low correlation in the data because, again, the true data generating process sort of dampens that relationship. However, bank balance sheet lending and bank capital, they have a high correlation because balance sheets actually matter. So the model that doesn't have these margins has to sort of jointly rationalize these things, and it has a very hard time doing that. A model that does have these margins active can do that much more easily and sort of hit both of these at the same time. Okay, so let me conclude. We do two things. We do measurement. We showed you that balance sheet lending is a poor proxy for bank lending and total lending overall, and that deviation is large and time varying, and it varies endogenously with a very important state variable in many of these models. We wrote down a model that has that active. We showed you sort of how a model that doesn't have these things active can make mistakes in terms of thinking through the impact of shocks to capital. And I'll sort of end it here with just some big picture comments on measurement going forward. Hopefully, we kind of underscore the limitations of only looking at bank balance sheets when thinking through lending. It's important to collect data and make available data on these margins outside of the residential mortgage market, where we know this thing is going on, but it's very hard to observe. And then without incorporating these margins, there's sort of a big scope for making sort of policy, macroprudential policy mistakes, not thinking through these margins. Okay, so I'll stop there.